Okay, so let's go ahead. Hello, everybody. Welcome to today's Tech Talk on distributed antenna and systems. My name is Nicole Gardner, and I will be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. We will be using the Q&A function at the bottom of your screen. When you have a question, you can submit them through that specific function. We will be gathering all of your questions throughout today's Tech Talk and leave a little bit of time at the end for Lynn to answer any of those questions. If your question is related to a particular slide, please include that number of the slide in your question. A PDF of the slides from today's presentation will be sent electronically to all of those who are registered for today's Tech Talk. We will also be recording this Tech Talk, and it will be available on our website under the resources section. Today's presenter is Ms. Lynn Gomes. Before joining the International Board of Directors, Lynn was on the California BCA board, and she's been on the board of the Conference Planning Committee since 2015. Outside of the BCA, Lynn is the MEP Fire and Commissioning Coordinator at DPR Construction. She is co-chair of the new IES standard on sequences of operations for lighting control systems and teaches classes on lighting control systems and will chair the upcoming revision of DG29, the commissioning process applied to lighting and control systems. So if it's technical, Lynn loves it. She also teaches classes on lighting control systems at the Pacific Energy Center and Light Fair. In her spare time, she is on the advisory board of TechBridge, an after-school STEM program for girls, who awarded her the, quote, Role Model of the Year in 2009. Welcome, Lynn.
Hey, y'all. Hey, y'all. Oh, here we go. All right. All right, today we're going to talk DAS and ERRCS, and we're just going to cover the basics because that's the point of a 20-minute Tech Talk. So here we go. All right, we got an AIA slide, just so you know, we all meet the AIA standards. So today we're going to talk about the background of DAS and ERRCS, rules and regulations, components in those systems, and testing as well. So let's talk about what we're talking about. So DAS is distributed antenna systems, and ERRCS is emergency responder radio communication system. They're very, very similar. I'll get into that in a little bit. But basically, the TLDR, the too long didn't read, is DAS and ERRCS are systems that repeat radio and cell signals within a building. And these could be for civilian or emergency use. And a pro tip, when you say DAS and or ERRCS, don't say DAS system or ERRCS system, because that's like saying ATM machine, right? Because systems is right in the acronym, and we don't want to repeat that. But why do we need these systems? Well, because of changes. Basically, there are new needs in the building. Lack of cell reception and emergency responder radio receptions during 9/11 started these changes and made them into code requirements. In addition, materials have new buildings now. Before, the internal partitions in a TI were made of wood. Now, those partitions are framed out with steel, and that steel acts like a Faraday cage, and that blocks radio signals. Also, as low-E glass has become more commonplace, we're also seeing a drop in radio reception because that blocks cell and radio signals, or that low-E coating itself blocks those signals. And then, hey, we got new changes and new expectations for how buildings are to perform. Well, not a lot of people have desk phones anymore, and people use their cell phones as their business phone now. So it's very, very important that we have an antenna signal within the building and you have reception in the building because, you know, you could miss a client's call. We don't want that. So lots of changes. So as part of that, take this off. All right, we have new rules and regulations are laid out in the International Fire Code, Section 410, NFPA 72, Code of Federal Regulations, Section 5104, and there's a little bit of interface with the FCC because they're regulating radio frequencies. But the really important thing to note is that code interpretations vary by the AHJ, and the rollouts were delegated to the AHJ. And so what that means is even if you go and you look through all of these codes, they're really performance codes, and the nuts and bolts of the implementation is variable depending on your jurisdiction. So if you're working on a project like this and you're going to be either verifying, validating any of this, or just facilitating that, definitely talk to usually your local fire marshal, and they're the ones who will be able to walk you through it. Some with some success than others, because this rollout has been extremely slow. San Francisco Bay Area has only started rolling it out in earnest this year, but they've been working on it and trying to roll it out over the past 2 years. Basically, these requirements apply to new buildings that are more than 3 stories high and that are more than 50,000 square feet. In addition, if you have subterranean parking, you also need to put in one of these systems. And it requires that you have a signal strength of less than -95 dBm in 95% of the area. And I'll show you what that means in a little bit. Okay, so these are the components of a DAS system. You have indoor antennas. You'll see these in buildings. Let me grab the laser pointer for this. This is an internal antenna. They generally look like a white cone that's sucked up against the ceiling. You have coax cable that connects these all to the DAS head end, which is basically a booster amplifier. And then from that amplifier, you have another cable that goes up to your outside antenna. This is what receives the cell or radio signals in a building or transmits them. And then all of this system is enclosed in a 2-hour rated enclosure, and this head end probably also communicates with the fire alarm panel. So lots of stuff to coordinate, lots of stuff going on that needs to be installed in a building. Here's another example, an outside of what and it shows you what an outside antenna looks like. There may be some grounding or lightning suppression associated with that. Shows you what your internal antennas look like. They just look like kind of a white, funny looking cone. Let's see, there we go. And then we have our, it may have a fiber system instead of coax. So we might have fiber coming in together. Similarly, your receiver just looks like a big box. And then the head end equipment, again, looks like another box. You may need to enclose, in addition to enclosing the cabling in a 2-hour rated enclosure. So you need to make sure that that you have room and you're coordinating where that's going to go. The main equipment may go into a data center. So you may need to have additional HVAC for this computer equipment. Just depends, especially if you have battery backups, which is a requirement for ERRCS systems, the emergency side of a DAS system. Okay, and so, for buildings, usually these are not included with the original design. And that's because you don't really know how well the cell signals in the area will penetrate into a building. Granted, maybe if your building's tall enough and you've seen other similar buildings require it, then yes, you may need it for your building. So what they will do is they will do a series of 2 tests, 1 or 2 tests. The first is done just to assess the building and whether or not you have good signal strength. This can be done, this first test can be done by a third party. Generally, it's more cost effective to do it by a third party in case you need to install the system. So the first test is done after you have most of your partitions and most of your equipment installed in the building, anything that could block radio frequencies. And then they go around and they test and they sweep the building to see if there are dead zones or zones that don't have enough cell signal. And if you have enough, right, that 95% criteria, if you have enough dead zones in the building, well, then you're going to have to install one of these. And so it's definitely a very in situ thing. It is definitely a risk for the owner. And speaking from the contractor side, you do need to carry that risk and inform the owner of that risk as part of the project. So if you need it, if that test says you need it, then you go back and they design a system and present it. And then once it gets installed, then you go and you do your test. So this is an example of a test from a project that I worked on. They're going to look for signal strength and do it by area. So this is a little summary page, and you can see here that they tested a bunch of zones, and this particular project passed. And thankfully for this project, we were able to, the DAS system that was installed as part of the base building worked for this particular building. And then this is what the test results showed. And so in particular, it showed which level they tested on, which area of the building, and the particular signal strength that was done. You may receive, you may get a really nice looking report that shows what your signal strength by area, where your weaknesses are, where your strong spots are. The strong spots, you can see that it's right near your, right near the repeater. The dead zones, of course, are further away from the repeater, but that's a fancier report. Yeah, so that's pretty much it in a nutshell. With that, are there any questions? Feel free, I'm here for y'all for, I don't know, the next 15, 20, 30 minutes, however long you want to ask questions. I don't see any in the open box, but you're free to ask me anything.
Thank you very much, Lynn. So we did get one question that came in saying, are there any challenges with trying into an existing system?
Yes, there can be. So with an existing system, sometimes the equipment is able to accommodate more repeaters, but sometimes you may need to install a brand new system in case it wasn't installed with that extra capacity. The other challenge related to that is just the interface from a base building owner and a tenant owner. These go on, there are some clients that want the base building and the tenant equipment to be on completely separate networks with an air gap in between. So if it comes in as part of the TI, you may need to install your own brand new system. So,
Thank you.
um,
Got another question here for you. What scope do you most often see missed when buying out DAS?
oh, the whole thing. For a lot of people, this is not on their radar because of the implementations with the AHJs. It's just a surprise. So again, you know, as commissioning providers, we are very good at understanding and managing and preventing risks. And, you know, depending on what your scope is with your client or the relationship with your client, this is something that you can give them a heads up on, and even do, you know, facilitate the review of, you know, either the preliminary test and or the final test.
Great. I'm seeing a couple questions coming in about emergency. So what determines the emergency system versus the normal DOS?
Very good. Yeah. So emergency systems obviously have to be a little bit more robust. The regular DAS, you may have, I've had clients contract with multiple cell phone vendors. So sometimes it can be vendor specific. On one project, it was T-Mobile and Verizon. On another project, it was solely Sprint. And their requirements for data centers are generally, or the equipment that goes in these DAS rooms were different. And sometimes they were the ones that were doing the design for these rooms. And it was owner procured, but we would manage the, me as the contractor, as the general contractor, we would manage the installation and coordinate with the other TI and base building systems. For ERRCS, definitely, you know, your radio signal is super strong. Sometimes the fire marshal would walk the building after the final third-party test was done to do their own verification that they had enough signal strength. In addition, there are requirements for battery backup for ERRCS that may not need to be present for a DAS system.
And piggybacking off that, are there some emergency power requirements for these systems?
Yes, there are battery backup and generally tying into a generator for that. And usually it's like 90 minutes. But again, you know, enforcement is up to your local AHJ.
And have you ever had a DAS or ERRC test fail, and what steps had to be taken to address those?
So yes, I have had DAS testing fail in that it was the first test just to see if we needed to install it. And, you know, okay, it failed. Well, we kind of knew that it could. Giant concrete building with, you know, steel framings on our TI partitions. So yes, it failed. And so then the next step after it failed was, okay, now we have to install a DAS system. Okay, who's going to design it? Who's going to install it? How much is it going to cost? What's this going to do to our schedule? And oh, by the way, we need to schedule that final third-party test, you know, for when it passes. And again, can we do this before TCO? So it's definitely a risk management activity in that you got to understand about it's going to take 4 to 6 weeks for design and installation or 2 months, depending on the size of the building, right? And we need to have that done before TCO. So we also need to make sure that at the start of this that we do our first test. And oh, by the way, for this first test, we need to make sure that most of our partitions are done and ductwork's installed and conduits installed, anything that could block a radio signal. So definitely a risk management scheduling kind of activity.
Okay, great. And is it the commissioning provider who needs to be performing these tests? And what kind of instruments would they need to do these tests?
So it's actually, as I understand it, and I've watched them do it, it's fairly hardware intensive. They have a cart that has a device that measures the antenna. They're, gridding up the drawings, gridding up the building, making a building grid. Let's see, do I have a good picture of it? Like they're creating a building grid that, this is all in your planning for them to go and take measurements into. So I guess commissioning providers can do this. I know that I'm not qualified to do this based on what I know in my experience. So I'm not going to go there for me personally. But if you have a good understanding of radio signals and you're willing to make the investment in the equipment, I would say why not? That said, I think this is a business all on its own. You could do verification of the third-party testing, but I just don't know that it's really worth your time. I don't know. That's my opinion. But as a commissioning provider, you can definitely read and review the test plan, right? And read and review the first results, the design of the system, especially for coordination, and then review the final report if you wanted to add that to your scope. I know as the MEP coordinator, I do review these, and I am actively assisting with the plans to both test these systems and install these systems. So yeah. But I think that's a good value add, is to do the review and make sure that they're good. And that it wasn't just a drive-by test, because nobody's ever seen a drive-by test, right?
And so I've got quite the question here for you.
Okay.
Is there a wire with UL certification that's been accepted by the local AHJ, such as Dragon Skin or Fireware, that would eliminate the requirement for 2-hour rated enclosures or 3M fire wrap?
Oh, that's a really good question. Carrie, I don't know. Do you know of an answer? I don't know of one yet. It's a very specific question. I don't know, maybe you could install it in conduit, but I don't know about that. And really it's the vertical riser that needs to be 2-hour rated. It's not the horizontal runs. So
Great.
Yeah, that's a good question. It's a stumper.
Well, then I think our questions have slowed down here. So thank you very much, Lynn. We really appreciate your time and expertise. Just a few announcements before we let everybody go. The next webinar in our spring series is coming up on May 10th. The presenter is Jeff Nichols with Engineering Economics, and we'll be speaking on ventilation for healthy buildings. There's also virtual training classes on new construction, existing building, and building enclosure coming up in June. So check out the BCA website for more details. On behalf of the Building Commissioning Association, I would like to thank everybody for your participation in today's Tech Talk, and I hope you all have a great day.